Hi. So today we're going to go through and show you guys your flight performance for the RFP. So for kind of wrapping up the semester, I wanted to actually let you guys see your vehicles fly, even though we couldn't build them in person. So in order to do that, I've kind of souped up the existing models. You guys should be able to see on my screen here. We're going to look at capacity, turning radius, basically endurance, the flight time, um, takeoff distance if you stay within the 2 meter by 5 meter area, and the ability to do a autonomous race course. So in order to do this, I've worked on a couple of packages here. One is a lift drag plugin. So if you want to look at the way that all of this is computed, there's stall model. It's basically CL, CM, and I've done that all here. Also, if you go into your, let's go into like team one, and I'll kind of show you the folder layout. And you can go see all this on the link that I gave you on Slack. And if we go in and you can click on your team here, then you should see all these folders. And I've got it locally downloaded on my computer, so you can look at the preview of your airplane there. There's also on the meshes, in order to get all the STLs to be lined up and everything, I found it easiest to use OpenSCAD to check all the parts and coordinate frames. So if you use OpenSCAD, I've got all the parts pulled in, and then I've got a bunch of things labeled here to figure out, certain things. I can turn these off, but so here's your center of mass, aerodynamic centers, joint locations, and center of mass for each part. So that's how I set up all these to make it finally work. And most of you guys got most of it right, but it was a lot to ask to line all that up. There's a Python script here that goes in and subdivides the parts and things to make it look prettier in the simulation and do collision models efficiently. If you have like thousands of polygons, it's a bad thing for collision. So that's what that's about. The main file here is the SDF file. So within the SDF, there's a rigid body definition called a link for the fuselage. And the fuselage, has a collision, which is the STL, a visual, which is the STL, and then I've got a bunch of frames here that's showing up where all the center pressures or the aerodynamic centers are for the airplane. Down here, you can see the wheel left, rigid body, the joint that connects it to the airframe, the right wheel, the rudder joint, elevator joint, aileron left joint. So basically go through, here's the propeller. Finally at the bottom, things start getting interesting. Alright, so wing, this is the aerodynamic plugin. The one thing I wish I'd ask you guys all for was CM0, and I changed the parameters here for this aerodynamic plugin to be a little bit friendlier. So CL0, CM0, CL alpha, CMA alpha, CD0, so this is our drag polar. I also didn't ask you for that, so I just assumed some numbers. If you guys want to play with this later, you could always go back and put the real data and fly your airplane around. Area, I corrected any typos that I saw here, like some of these were off, just by a decimal point or something. And also I standardized all of these. I went in and did some XFLR5 analysis on flap deflection and found that this is pretty standard for a cambered plate, flat plate. So everybody got the same values here for control deflection, so that I can see if anybody's got an undersized control surface. Because if you have a huge area here, then this coefficient, is not using the area, so the area is multiplied by the coefficient. So if you have a big enough surface, these should do what you need to. Same thing, right wing IMU. This is kind of the PX4 hook in, so it actually talks to Q ground control and everything. It's got inertial sensors like gyro, magnetometer, GPS, magnetometer, baro, and now here's the motor plugin, which is the other one that I worked on with ZP for this course. So it takes in two polynomials so that you guys know when we ask you for this for advance ratio versus thrust coefficient and power coefficient, kV for the motor, I0, no load current, maximum current, R0, so is the battery or the motor resistance, battery voltage, battery capacity. I just added this support, which basically tells you how much endurance you have, motor efficiency, and I assume this number, since I didn't ask you for it. It would be nice to base this off an RPM eventually, but right now it doesn't. And that's basically it. This is the Mavlink interface that talks to EQ ground control. Down here is where I have all the trims and everything. So for Team 1, I bumped your throttle up by 10% to get the cruise throttle where I wanted it. Aileron left, aileron right, elevator, and that's about it. Now, all the teams are there. They all work the same way. I'm going to record flight logs as we do this. So when you launch ROS like this, it's going to dump all the logs to .ros. And I'm going to clean it out so that we can record the logs as we go. Eventually, I will put all the logs in the data directory, and it'll be there for you to access on the website. So in order to access them, you would just go to fixed wing gazebo data, and you can already see I have one ULG file here. I'll just get all of them for all the teams and upload them, and I'll probably name them so it doesn't get confusing. So this is going to be all the teams stuck together, all the data collection, and let's go ahead and start. All right, so if we go and this is using ROS, which I didn't teach you guys, but it's good to learn about at some point. I'm using a Catkin build to make sure everything's up to date. This builds the PX4 software in the loop simulation for the autopilot. It also builds the package for all of our airplanes. All right, now I can do ROS launch, and I'm going to ask for fixed wing gazebo, and I'm going to show the fleet. So this shows every vehicle in the class, and they're started pause, so you don't actually do the simulation because it would talk to this many autopilots, which talking to 14 autopilots would take a while. So if we look at transparent and center of mass and joints, this is all the stuff that took so long and I had to get lined up to get you guys an accurate simulation. So you can see everything's in the right spot. I have also put these little axes on here that represent the lift. So basically the airfoil that I'm assuming. So it basically assumes a 2D airfoil model, and then these are the aerodynamic centers. So the blue arrow is the direction of kind of the camber of the airfoil. The red axis is the chord line. So I tried to line this up. So if we look at this slice for Team 1, I'm lining up the camber direction is blue. So that's the direction lift is going to get generated, and the chord line should be aligned with the red arrow. Same thing, horizontal tails. I standardized most of the horizontal tails are going to generate lift down to balance the pitching moment. So the blue arrow is down, red arrow forward, green right. Vertical stabilizer, for the rudder, etc. Same thing, blue to the left, and I built that into the aerodynamic plugin. So you can go over here and look at the source code for this. So models. So where's that defined? Well, that triad shows up here. The little axis that I drew is this visual, which is pulling in an STL model of the axes. And wing left, this pose is what determines where it's actually going to generate the force. So I have that pose occurring two places. One just to draw the visual, and then one in the actual lift drag plugin to generate the calculate the angle of attack, side slip angle, and then the resulting velocities, calculate the lift and everything else. So that's how that works. So you can see that team 1 has some dihedral in there, and that rotation's in there based on that 6 numbers that represent the pose, which are XYZ, roll, pitch, yaw. So team 2, let's refocus. Okay, team 2. Okay, centers of mass, aerodynamic centers. Team 3. Okay, team 4 is the flying wing, so it's a little bit different. It's got 2 motors. This one took a little bit of time to get set up correctly, and they're both counter-rotating props. Okay, team 5. Okay, team 6. This one, you guys, I don't think have gotten me an STL file for the new aileron yet, so I just left it as is, but I'm treating it as a regular aileron, so the dynamics won't change. Team 7. This one had a little incidence angle on the wing that I've included there. Okay, now at team 8. Okay, team 8, I've noticed you guys didn't have much of a dihedral angle in there, and you're using rudder, so that was kind of hard for you to turn. Also, this is a relatively small rudder, so I had, in flight testing, we'll see that. But overall, it flies really well and nice, easy flyer like you're going for. Team 9, pretty big, low wing loading, so that's nice. Pretty straightforward. Doesn't have a rudder, but these guys don't really need a rudder too much, I don't think. Team 10, pretty cool. Team 11, so this is the lowest wing loading out of anybody, and really can maneuver around the race course, which you guys will see in a second. I can go ahead and insert the race course so we can talk about it real quick. So there we go. So you can see the race course over there. There is it's basically like a skiing course. So there's a green course, which is easy, and I forget what I set the meters at. I think this one is, I think it's 10, 20, 40. So that's 40 meters between poles, 20 meters between poles, and then 10 meters between poles. And let's go back to vehicles here. Team 12. Pretty cool gull wing design. 13. Team 14. Alright. So if any of this looks off, let me know and I will go ahead and fix it. But I think everything is flying and everything looks pretty good. I noticed one of the biggest things is that if the pitching moment was off, I modified the CM0 to make it work. But you might need a bigger horizontal tail when you actually build the airplane. I've included comments in your models. So for instance, if we go to if we go to team 1, they say check CM0 may need a larger horizontal tail. So I've done that. If you plan to build the aircraft, those are things you might want to look at. They're kind of feedback from flight testing. And everything should be tuned and ready to go. So I'm going to go ahead and close our fleet view. Alright, this is where the log should show up. So let's start up team 1. So you can see in the README here that I've got the launch instructions for starting your plane. Everyone except the twin engine for Team 4 is the same, so everybody else would just type this instruction. Team 4, we have to say that it uses a different startup script. It has to use a twin engine script, and that's it. And there are also instructions on how to build it if you look up how to use ROS. So ROS launch, fixed wing gazebo, we're going to call px4.launch, and vehicle is equal to mini fixed wing 01. So this is pretty cool. In this bottom window, we have all of the output from the motor plugin. So we've got advance ratio, overall efficiency, which is motor efficiency times prop efficiency, power coefficient, thrust, voltage, remaining capacity, minutes, and this is remaining minutes of flight time at this current draw. The no-load current is already drawing 0.5, and the RPMs are at 0. On the right-hand side, we have, so here's a heads-up display from Q Ground Control. We have the relative altitude, ground speed, flight time, and all this. So we should be good to go. You can see this is the last course that I flew. Team 1 is sitting here ready for takeoff, and this is kind of the green course, the blue course, and the black course. All right, so I will leave this on something that I can kind of fly. I'm going to get it up and put it in position control mode. You can see that these cones here represent the takeoff distance. I believe it's 5 meters to the first set and 10 meters to the second set of cones. So let's jump out real quick. So to meet the requirement, you basically have to take off before the first set of cones. And if you take off by the second set of cones, I think we're pretty safe. But that's kind of what we're going for. And I understand that this simulation model, it was kind of a lot of work to get everything running, and you guys haven't had time to give me feedback. So we're going to take that into consideration when we're grading, and I don't want you guys to stress out. I think this is more for your fun and enjoyment, and also to give you some actual feeling of accomplishment for the course and actually see everything come together. And like I said, I'm happy to fix your models, but yeah, let's just have fun. So if we go ahead and look at, I think if you clearly didn't mean a design objective or one team is really doing well, I think that will factor into the final report grading slightly, but that's about all. So now let's follow the plane, and let's go ahead and start it up, and I can actually tell PX4 to take over and launch it for me. So I could say commander takeoff. This is the PX4 command line that's actually running on the autopilot, and this should work. And that was a pretty quick takeoff. If I did it manually, I would be able to do better, but Team 1 can definitely take off pretty quickly, so good job on your takeoff distance. Now I'm going to take it back to manual mode and do some flying. Alright, so now it's in manual. You can see it's pretty stable. It doesn't take much to fly this thing. I can get around the green course easy in manual. And I'll try to do some cool camera work here. If we go into there we go, GUI, and I switch around the camera so that it's not just boring view the whole time. So I can take inherent yaw off, which is kind of cool. So we get kind of a cool view of it flying around. This one is also really hard for me to fly it as a pilot though, so I'm going to take that off right now. So here we go. Blue course for Team 1. I'm going to switch it over to acro mode. Alright, So we're losing some altitude there, but it definitely gets it around pretty easy. All right. Now I'm going to go into position control mode for the black course. Position control mode will basically let me fly as I want to. The one thing I want to do though is set one of the gains so that we can be a little bit more zippy. So this fixed wing roll rate feed forward, I'm going to bump this up to 1. So you can see that gives me a little bit snappier response there, maybe even 2. So let's give Team 1 every chance that we can to make the black course. I'm going to get the altitude a little bit lower so we're kind of in line with the poles. All right. And just too quick on your wing loading is a little bit too high to make the black course. But you know, overall pretty awesome. I'll try it on acro mode. Yeah, we just lost it. Okay. So Team 1, good job. Made it through the blue course and the green course without any issue. Just a little fast for the black course. So let's take the zippiness down a little bit. Okay. Oh, that was an acro. Ooh, bounce. I'll try to go in for a nice landing and then we'll wrap it up. So go to stabilized mode and drop the throttle down. You can see we had plenty of flight time with Team 1. We're still good on our capacity here. We only used around 300 milliamp hours, and we're disarmed. All right, so I'm going to kill Team 1. Let's go and look at our logs. So we've got this 073551 log file. I'm going to move this to data, and move 073531 to 0735 Team 1. Just so it's labeled so you know who flew what. Now Team 2. Let's take a peek back at the RFP and make sure I'm hitting all the points here. So PX4, low cost, takeoff weight, flight time greater than 5 minutes while racing, avionics, payload, turning radius 2, straightaway, takeoff distance. Yeah, okay. So Team 2, I'm going to take off in manual. Minute off by about the second line. It's pretty good, so it's a 10-meter takeoff. So I'm going to switch it over to stabilized mode. This one, you know, kind of a little bit less stable in regular flight, but pretty zippy on the turns. So I'm going to do acro mode. Oh, there we go. So no problem with the green course. I'm going to try position control. Okay, try to get a little bit zippier here. 2. So really nice turns. Try to slow this thing down a bit. Get some altitude down. Yeah, there we go. All right. Easily handling the blue course. All right, It seems to be a little bit of a phugoid here going on. I could probably tune that out. It wants to pitch up a little bit, but all right, black course. See if I can get it slowed down, get it low enough. All right, nope. So wasn't able to make all the black chorus, but overall a great flyer. So great job, guys. So let's go in for a landing. Down in manual, try to land it in manual. Dropping throttle. Oh, need to bleed off some more speed here. And I'm flying this with a little gamepad, so it's a little bit tricky, but I've got it set so that the joysticks hit it about the right spot. And you can see landing distance isn't too bad. I've got the damping ratio kind of set for the wheels so it can slow you down. So if I'd made a better job of landing, that would have stuck within the allotted 5 meters. So endurance, we're at 68 milliamp hours left on the battery, so great job. And let's go ahead and kill. We should have the flight log. Let's go ahead and check before we jump off. 740. So I'm going to move this to data team 2. So let's do this first. Move 07 to 07 team 2. Move 07 team 2 to all right, and let's take a quick break to talk about flight review. So if you click here, I've said you can use flight review to analyze the flight data. So let's upload one of these so you guys can go through and see what it's like. So now if we go to Swing 0 data and we upload team 1, so it creates this, shows all the different modes we were in. It'll actually play it in 3D. You can see this early. You can send to any of your friends, and they can view it on even a mobile browser, like a whatever. So it's pretty nice. If you go through here, it's color coded by mode. You can even switch over to 3D view. You can look at our set points and how well we were tracking. So roll angular rates. So if you're looking at basically how well the PID controllers are tracking roll angle, this is how you would kind of look at that. So you should see kind of a lag in the response. It looks like we have some roll rate estimated, roll rate set point. So it looks like we have some oscillations in roll there that we could fix. We haven't even tuned this vehicle, so I'm just using the default gains to get us by for today. But that's kind of the idea. Definitely some oscillations we could clean up. All right. So the other cool thing is the 3D view. So let's look at that. Up here, open 3D view. So this is in the browser. Will show a 3D view of the entire flight, and then you can look at manual control sticks. So we can play it along here, and it's showing it over the 3D, the GPS position where it thought we were at, which is set to Switzerland by default. So this is while I was on the ground. Finally got in the air at some point here. Oh, there we go. So I didn't realize it was on the ground armed that long. Must have been talking. Alright, so right around there, tick off. So let's start it. Oh, we can increase the speed here. Let's do that. Yeah, well, 120x is a little crazy. 10x, we should make sure everything's there. Alright, so really useful, really fun to play with, so definitely check this out and have some fun. Alright, so I'm going to close that down. Let's go to Team 3. So Team 2's battery is still draining. So this endurance in minutes is basically capacity remaining divided by the current draw at that time. So that's why it goes so high. So the crouton Mickey, here we go. So I will try a manual takeoff. Jumped up really quick. Alright, I'll switch it over to position control mode. Let's go to acro mode. So pretty agile. I'm going to floor it. As I floor the throttle, it pitches up a little. And I don't have much elevator. Looks like my elevator's kind of maxed out. Let's go to manual. Okay. But overall, pretty cool. Flying pretty well. Easily can make it through the green course. Try to get it over to position control mode and see if we can go through so I think I need this in acro right now. This one's just not tuned for this aircraft very well, so I think it's the cruise speed or something. Okay. So in acro I can get it low and then we'll go over. Oh, touch. So, oh no, oops. Hopefully I can take off. So that's this is a good example. I want to show you something real quick. So the CM0, wasn't very well balanced for this aircraft. I thought I had tuned this in, but let's adjust it real quick. And this could be actually fixed, with adjusting the horizontal tail size, things like that. But currently, to get everybody flying, I just instead of changing your geometry, I changed this value. And having a positive value for a cambered airfoil doesn't make any sense, but gives you an idea of what it would be like if this thing were balanced. So let's try that again, Team 3. Okay, let's see if I've got, yeah, so it needs a pitch up quite a bit. I think I went the wrong way. All right, let's give that a shot. So since we know we didn't have too much time to make sure you guys had all the right parameters and give you feedback on this, things like this, the balance issues. I don't know if it's my simulator or if it's your design, but I want to give you the benefit of the doubt. So that one, it seems to be climbing too much. So this gives you an idea of kind of how I tune them in. I just set it to 0. Ideally, it should be something like minus 0.1 for a cambered like flat plate at 0 angle of attack, the CM0. Yeah, as long as I give it throttle, this is okay. But it needs, to get it really tuned in, I need to give So I think on this aircraft, if you had a little bit longer moment arm on the horizontal tail, it would be good to balance it out. And that's effectively what I'm doing here, just by changing the aerodynamic coefficient. But this is basically set for the airfoil geometry, so there's no reason to do this here. And the real change in real life would be on the actual design of the horizontal stabilizer. But this isn't just you guys. I mean, everybody got this a little bit off, and that's kind of expected. Okay. And if your control surfaces were big enough, you can accommodate this, but sometimes the control surfaces, like this is a fairly small horizontal tail, so I don't have much control authority. It looks like we're approaching where we want to be on this thing. Bump it up one more time and call that good. Alright. There we go. That's flying pretty well. We're losing a little altitude. I give it one more bump. Alright, that flies pretty well. So let's see if I give it some thrust. I'm climbing pretty steeply and I can't push the nose down. But overall, pretty agile. Go into acro mode. Oh, yep, okay. Go into position control. Okay. gonna tell it to try to descend here. What's our airspeed? It's 10 currently. Okay. So I can adjust the trim airspeed with my left stick, and the right stick is basically altitude and roll command. The left stick also has yaw, but we don't have any rudder on this aircraft. So easily made it through the blue course. And very nice handling performance there. I've got full down stick, so really I really want a bigger elevator. Going for the black course. Nope. Pretty close. Pretty close, but not quite. Missed one. Definitely the most agile one we've seen yet. Oh. And this guy has an interesting thing on landing. It likes to nose down. So as soon as you basically let's restart it and show you from the air. The way the landing gear is on this, it's a pretty big landing gear, and as the plane is stopping, it has a tendency to kind of land on its prop. So that's one thing that I would think about for the design is trying to save some props, because let's go up and spin this around and go in for landing, and I'll show you what I mean exactly. So do another cool camera view change here, and take inherit yaw off. And I was debating about if I want to remove those triads. They kind of look goofy, but I thought it'd be good for you guys to see where I put that data. So alright, here's our nice landing. Let's see if I can stop in time. So definitely stopped in about 5 meters, but then right at the end you see the nose over. So that's I just basically is this really big landing gear relative to the aircraft, and you might break some props that way. But overall, great job. So, and capacity, I don't think we had any problem with any of these groups so far in the 5-minute capacity. Let me see. I'm not sure if I checked, so I don't think it was an issue, but I want to make sure. Okay, so it's saying 5 minutes if I'm just flooring it the entire time, so that's good. Cruise more like 15 minutes cruise, 20 minutes cruise, so pretty good. Now I've got a bunch of log files of these guys, and we have to find which one was the best. So I'm going to see which was the biggest. It should be the biggest, this 1.9 meg or 5.8 meg, 759. So copy 759 to 0759 team 3. And make sure we're getting our these populated. So we got 1, 2, 3. And make sure I save my changes to team 3's trim there. Okay. Now team 4. do a sanity check on my recording here to make sure. Okay. So Team 4, one of the hardest ones to model. It took me a while to get this one. So you've got, a flying wing, twin engine, and you have to get all this right and get it to actually fly. And overall, it's pretty hard to fly in manual. So I'm going to take off in stabilized mode, so it handles all the quick reaction time for me, so I don't have to do that. Pretty hard to fly this guy in manual. So here we go. I'm going to got a 450. So this is two different batteries. So we're talking to both motors here. So really, we've got around 950 amp hours remaining. So around 900. So I'm gonna go up. I go to stabilized and give it some gas. All right. Oh, yep. Forgot to write wrong there. Yeah, right script. This is the one that uses a different script. If you look at the launch file, for those that know how to use ROS, if you look at the launch file for px4.launch, it has everything start up here, and the argument that it takes for script is the script that px4 uses to start up the autopilot. And this guy just needs a different script besides plane. It needs the script plane underscore twin. So here we go. Same thing, fixed wing 4, script colon equals plane underscore twin. All right. Now we go to stabilized, lower the throttle, arm, ready to arm, and then give it gas. Oh. So because there's no just skids on all this, and this guy has a lot of torque, any kind of yawing on here is really kind of hard to avoid. So it's hard to get this guy to take off without kind of spinning in a circle initially. I kind of have to give it low throttle to get it rolling, and then I can gun it. So I'm going to give that another shot. So stabilized, armed. Oh, there we go. Okay, so now we're up. You can see that it's got a little bit unstable until it gets to the flight speed it wants to be at. But this guy has some really cool features. Pretty nice, glide slope there. I'm going to bump up the speed a little. I'm going to put it in position control. And once it's in position control, we don't care that, it's not very stable on its own. We're basically letting the controller do all the work instead of the pilot. So here's rolling with ailerons, and that's one way for this thing to yaw. The other way is through basically using the motors. And you can see it really zips around when I use the motors to yaw it. Let's switch the view. Let's back this out a little bit and go up top. Alright, so now check this out. So this is basically a turn using the ailerons, and this is a turn using the motors. So, a pretty nice contender here. Let's see how it does. So I'm going to switch back to my view where I can see. Go to 3, 2. Okay. So we're still in position control. See if I can find the race course. Go for the blue course next. Oh, and I've been talking a lot, but this one we got 2 minutes left on battery, it says. But so that would put it at about what we'd expect. So in position control mode, it's getting through the blue course, but not easily. So, oh, acro, I'm not able to fly very well. Stabilized, let's try that. Okay. It needs a little bit more trim throttle. So stabilized, I can fly it. Acro is a little bit too much to ask. Our airspeed right now is around 8.9. Oh, losing altitude. Going into position control again. Oh. So this one, I think, since we're relying so much on the controller, could really benefit from some gain tuning. I just don't have time right now. But it's got this pitch oscillation that we kind of have to damp out, and naturally has it. I have a hard time avoiding it myself, but the autopilot should be able to damp it out. All right. So we're in position control mode, flying pretty well. I'm going to try to get through the course using ailerons, and then give it a shot with the yaw differential on the motors. Oh, so it kind of went unstable and couldn't recover. So I'm giving it full stick to recover it. But so ailerons, I'm having a hard time. I can't bank as much as I need to in this position control. So try in stabilized mode, and I think I need to play with this gain. Yeah, I think I have to play with the gains a little bit here. So this guy is, bump that up again. Okay, and where are we at? Position control, save. All right, take that up, trim. All right, sing. Oh, we're out of battery. So this guy running two motors with a 950 milliamp hour battery is pushing it. So let's check it again. Okay. Oh, yeah. There was my manual takeoff. You can see, oh, stabilize is having trouble as well. And it's possible, some of this is simulation fidelity. might be a little bit easier to fly in real life, but oh, there we go. So now we got it. So going pretty well so far. Switch to position control. Alright, so now I added a little bit more oomph to this rate here, so I can push it around in position control. But I can also do it with yawing, and look at that, that's just insane. I need a little more trim throttle because I'm losing altitude slightly. Oh, there it goes. Okay. So I'm just kind of scooting it around using the motors. Now let's try for the black course. And I guess I'll do blue because we haven't done blue on this one yet. So really cool differential thrust maneuvering. Just lets the airplane stay level. Minimize that window a little bit. Alright, and this, it's got the full autopilot here, so we could command some waypoints. We could say, go to position here, right? So we could say go to that point. And now it's taking over an autopilot and trying to get to that point. Alright, now it's going to loiter around that because it's fixed wing aircraft. And that's basically what we have to do. Well, let's say I want you to go back to the race course now, so go here. Alright, so now I'm in armed hold mode. It's going to that position. I'm going to switch it over to position control so I can control it. And we'll try the black course with differential yaw. Basically did it. So I think this guy wins on agile. If I had time to fix the gains, definitely. I think endurance is really pushing it pretty close on this. Definitely, if you did some path planning and took time to do that, you could have made it through there with this aircraft. I would have liked a little bit lower wing loading to see if you could kind of make it more of a floater that would have made it through. But as far as a race vehicle, it definitely has a lot of capabilities. So very cool job, guys. So now team 5. Oh, before we do that, let's not forget the log file. Copy 08 15 to get then over here. Team 4. Alright, and now let's go and do the next team. So team 5. Alright, so let's take a look around the aircraft here. Alright. So we got a rudder, aileron, a little bit of dihedral, elevator. So yeah, I think should be interesting. Let's give this guy a shot. So let's see if we can get some auto takeoff action. Very nice. This just jumps right up. very smooth and controllable. So switch to full manual. Oh, sorry, full manual. Really nice to fly this one. Could just be after the flying wing, which was a real challenge, but yeah, this feels great. Okay, I'm gonna go to acro mode. Oh, I lost a little altitude there. Go to position control. There we go. Let's drop some altitude. Oh, a little too much altitude drop. Alright, go for the blue course. Oh, I'm having trouble getting through the blue course with this guy. So a really nice, kind of slow park flyer, but let's see if I can. I bet I can get through the blue. Just maybe take it out of position control, go down to acro, stabilized. Alright, stabilized. Yeah, that'll be nice. Something is goofy with position control on this one, just the way the gains are set. But this should make it through blue just fine. Well, I think we might have a shot at black with that. Nope, not quite. Alright, let's go up for a landing. Go full manual for the landing. Alright. So great job. I really liked how that flew. So before we didn't have a 19, so it's the 19. So move 08, 19 to 08, 19, team 5. All right, and just clean that up a little bit so I can see the new ones. Kill. Let's go for team 6. All right, we got a 800 milliamp hour battery. Let's try an auto takeoff. Really cool since we already have this up here. This is got the whole autopilot, so you can go in things and look at the estimator, and this is the extended Kalman filter running that's actually taking on the simulated data, other things that are happening there. So a really useful way to prototype software. So now talk to this thing, say takeoff. Made it up without issue. Really nice flying as well. Let's try to take it over in full manual. Alright. Oh, I'm going to hit the pole. Oh, I lost him. That was my fault. Good thing about a simulation is we don't have to glue everything back together. So I think, I'm just banking a little bit too far, losing too much altitude. Let position control to do the work for me. But overall, pretty snappy. This is the team that's got the extra large ailerons at the moment, but that was just a visual thing. Nope. Position controls trying to climb way too high. I don't know what's up with that. I think it's the cruise speeds might have to be adjusted. I'm going to take it over and stabilized. Yeah, stabilized seems to be what I want to do this. Okay. No issue at all with blue. So we got 3 minutes of battery left, so I'm doing fine on battery for this. Probably not going to make it. Alright, let's give that another shot. If I can get this real tuned in with position control, maybe. And get it hovering low enough. Alright. Nope. Alright, go to full manual. Let's do a landing and stabilize just for fun. Alright. A little bit easier for me that way. Cut throttle. Alright, great landing. So, great performance. We got plenty of time left on the battery. Alright. So we got our log file written. Team 7. an auto takeoff. Alright, jumped right up. I think the auto takeoff exits it to get to 50 meters, so that's why that's a little insane initially. You can definitely adjust that. Mission takeoff altitude is 30 meters. Let's say that it's 15 now. Alright. Now it's in full auto, so let's take it back over. So tried to goose it, and then this, oh, let's go to stabilized. It's got to recover here. Oh, needs some more gas. Oh, okay. So giving it a lot of throttle gives me a lot of pitch up. A little bit hard to deal with. Feels pretty good. So pretty nice turn radius there. Don't think we'll have any issue with blue. Let's see if I can lower the lower this guy a little bit. Let's say cruise is 8 minimum. Alright. Let's see if that helps us with position control at all. Oh. So we made it through green on that real easy. I'm just going to go through straight to blue. And to get us through a little bit faster, I think try to stick to blue on everybody and then go to green if we have to. This is really nice. Don't know if we'll make it here, but nope. Almost though. Just missed one column. Let's give it another shot. Try and stabilize. Oh. Nope. Alright, let's spin around and well, it's unfortunate that I can't show you a landing. If I can make this one log file. think if I spin it, the autopilot will get upset. Well, I'm sorry, we're gonna have to do this guy again. All right, jump up, quick pass through blue, and go for it. Oh, acro, I didn't want to do acro. All right, I want to do position. So, no issue there. Let's pull up airspeed. That would be more interesting to look at. All right, and then line up for black. Oh, missed it. Pretty close. All right, now for our landing, go into stabilized, start cutting throttle. Oh, we got a nice glide slope here. We're not going to make it. All right, nice landing. Okay, now we stop it. We should have a new log file sitting here. So we're going to move this 0836 to 0836 team 5. All right, so we should have team 5 there. data now. Sorry, I think I messed up on the number here. So that was team 7. And we missed one of them. Missed team 5. Alright, so we're looking for timestamps between 8:15:02 and 8:24:33. (8:15 to 8:24). I don't see anything in that range. Let's make sure we did team 5. Yeah, we did team 5. I'll get you a new log file just in case, so I don't want to cause any issues here. And I can't go back and look at my video right now. You guys will probably see what I did watching it. But so let's do follow arm. Okay. Pretty nice. Position control. Oh, position control needs some more tuning. Alright, made it through blue. Turning radius, nope, can't make it through black. Alright, go in for a landing. Alright. Alright, we got our log file. Oh wait. Oh wait. Alright, and let's see if we got everything here. So 1, 2, 3, 4, 5, 6. Well, this is going to be confusing if I don't rename. I'm going to change my naming convention here. so let's do have everything sitting here, and this 1102, don't need that, so we should be good. 1, 2, 3, 4, 5, 6, 7 on team 8. Alright, so an 850 milliamp battery. This guy is the team with just the rudder, and the control surface of the rudder is super big as well. So it's really kind of a slow maneuvering vehicle. Definitely can make it through the green course, but has trouble on the blue and the black. So our flight time looks good. We're at cruise, we're at 5.3 minutes flight time. And if I pull back on the elevator, I can get a little bit better turning radius from this. Oh, but I'll count that as a success on green. Let's go for blue. Alright, switch our view. Just to get a cooler view for a little bit. This one I also added some dihedral to it. I don't think you guys had quite enough dihedral for it to be a good to really kind of get the turning in with the rudder. But it could have been, the modeling on the control surface. I think if you had a bigger control surface back there, that could have also fixed it. So, but yeah, definitely need a little bit more dihedral on this guy. All right, so let's set back to inherent yaw. Try to get through blue. I don't think it's going to happen. But definitely, simple plane. This one was really quick for me to model, as well as it should be really quick for people to build. But yeah, just not going to make it on the turning radius. All right, so let's go in for a landing. Oh, so I just hop back up here and land again. Yep, quick to land. Kind of noses over as well, like Team 3 did. But other than that, looks good. Let's look at our log file. Move 0846 Team 8 ULG. Alright, we should have 1, 2, 3, 4, 5, 6, 7, 8. Go for Team 9. Manual takeoff. Got a 5-minute flight time. Alright. No issue getting through the green course. I'm having to play with the throttle a little bit if I get in the position control mode. Yeah. Alright. Let's try blue. So really nice actually to getting through blue there on the position control. Pretty nice turning radius on this guy. Let's give black a shot. Yeah, look at that airspeed. 7.7, 7.5. One of the slower ones we've seen so far. Oh, there we go. First team to do it. So Team 9, great job, guys. Alright, you go in for a landing. Oh, hit the cone. All set. So move 0852 to just keep track of this. So capacity, flight time. So yeah, so we got endurance, radius, and then takeoff. All right. So team 10. All right. So let's go for team 10. All right, we got nice battery. Let's see how it goes when we go up. 5.7 minutes battery. Good job. Now, green course. I really like the way this guy's flying right now. Losing a little altitude there. Switch it over to controller or position control. Yeah, it's got a nice turning radius. Oh, let's lose a little bit too much altitude though. All right, so blue course. No problem on the blue course. Let's go for the black course. Nope. Oh, hopefully I can land it. Yep, okay, we still get a landing. Oh, maybe. There we go. All right, go in, stabilize landing. All of these don't have too much elevator. It seems like all the tails are pretty small, so it's hard for me to do a flare. But looks good. So let's take this guy. And we've got team 10 there now. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's go ahead and commit this so I don't lose it. Alright, so Team 11. And Team 11 had the lowest wing loading, so hopefully they'll have a nice slow flight. So this is another ski takeoff, so hopefully I can keep it straight. Alright, nice takeoff. Airspeed around 10 meters a second. Let's see if I can go to position control mode. So I'm holding it down. I can get it down to like 9. I'd like to see this go lower, but definitely a sharp turn there with all that wing to pull us around the corner. Oh, I crashed it. Let's see. Went into a spin. Let's give that a reset. Alright. So endurance looks really good for this guy. We're not using hardly any motor. Oh, there we go. Okay, now once it kicks in, I have a hard time believing something might be a little goofy there. Basically, just gliding around the race course at this point. Maybe they're more aerodynamic drag. Alright. Yeah, something's happening with my efficiency there, so I don't know. Overall, getting around the blue course easily. And get it in stabilized. Try to help me hold the altitude here. And then go for black. can get this going at around 9, I should be okay. Nope. Let me give it another shot. I think that's my fault. So I think, I think I can probably pull this off, but it would be a lot easier if there were, it would be a lot easier if it were just a little bit slower, which I think is maybe just a trimming issue on this, where it's kind of set up to cruise at 10 meters a second, which I think is what you guys designed for. But to hit this turning radius, I think we need it set at a little bit slower velocity. And maybe we just don't have enough control surface to do it right now. You guys have pretty big control surfaces, but maybe my modeling of it isn't good enough. So I don't know that it's your fault. Just has slightly too much throttle. There we go. I don't know if I can. Yep, I don't think I can do it. I'll make one final attempt. Starting at pi, almost, just a little too much there. All right, final pass, then I'll go in for landing. Oh, so close. All right, dropping into manual. Oh, jump up. Let's try landing in the right way. All right. Good landing, good endurance, and good turning radius. I think it just trimmed for a little bit faster flight than this race course. All right. Let's try team 12. So move 9, 8, Okay, it's the gull wing design, and it's a low wing, so it should be pretty agile. So let's just give this a shot. It's got a pretty high wing loading though, so it's going to be pretty zippy. Looks like an 850 milliamp hour battery. Oh, almost wanted stabilized to take off. Oh, yeah, going into acro I had issues. Okay. So it flies pretty well and stabilized. Let's give that a shot. Looks like there's acro. Oh, okay. Give a stabilized a chance here. So I think as modeled now, there's just a little bit of a roll instability or something. And this is something the autopilot could be tuned to fix. And just, kind of that low wing design. Let's see if we can get through the blue. Oh. I think I want to do acro. So I'm holding a lot of back stick on trim, so it could be like an issue with the trimming of it. Definitely get some better performance if I do that. I think we're going to have to tune this a little. Let's see if we can get an auto takeoff. Yeah, hops right up. Auto takeoff looks good. Now, this fixed wing airspeed, I think this guy's quicker. Let's set it up to trim airspeed of 10, even 15. And we're going to set the fixed wing roll rate, feed forward. Let's go to stabilized. Yeah, it's just a little bit jumpy there. So that's definitely better, but so no issue with green, but I think with the the wing loading and the stability issue, it's going to be a hard time getting through blue. I'm going to pull this up real quick to see if there's anything that we see if I have the CG in the right spot. All right. The CG could be a little bit far forward, but that I think could be what we'd want. So let's see if all these frames accurate. Looks like it. Let's look at inertias. Drag this out by itself. Oh, grab the wrong. There we go. If we can get this out by itself and see if any inertias look reasonable. Alright, it looks like the inertia for the looks like we have wing inertias modeled. and there's a very large inertia for the elevator. And for the mass of that, those are probably really big, and that's what it's representing there. So we'll say that this is and those have to be the ailerons. So all right, so let's see if we get any difference there, and then we'll see if it behaves better, and if not, we'll do some gain tuning. All right, those are starting to look more reasonable. So let's give it a shot. I don't know if it'll change much. Those are pretty small inertias to be dealing with for the overall plane. I think the main thing is basically the center of mass relative to the aerodynamic centers here. So it looks like, the center of mass is at the same height as the aerodynamic center of the aircraft. So I think that that's the main contributor. So let's go in. You can also try turning the servo speeds down a little bit. I don't know if that'll help. We don't have full deflection there, which I think I tuned that down because it was a little bit crazy before. Let's put it back to full. And let's turn this down to 5. Let's make it a little slower response, but less jittery. So we're basically just stalling and spinning out. I'm going to see if there's anything else I can do, if there's anything with the aerodynamics that I can spot. Okay. Ah, LCMA. So H-tail. Looks okay. V-tail. Looks okay. Left wing. Wow. That's going to give a very large CL max because the CL0 of 1 with a CLA of 7.75 with a stall of 0.122. So 1.085 times or plus 7.75 times 0.122. Okay. So it's getting up to 2. And I think this is a little bit crazy. So I'll have to look into your guys' report on what you've justified here. But let's give it a shot. Let's see if I'll get the best log that I can. I think as long as I don't deflect too much elevator, everything's fine. Yeah, just when I deflect the ailerons too far, I get some crazy responses, which ailerons are tied to the wing. So I'm going to try some a little bit more reasonable maybe. So what does that give us? 0.5 plus 6 times 0.122, 1.2. So CLA, CL0, CLA, which we had, and CL0, CLA. All right. See if we get any difference. Alright, so now we're getting a strong downward moment. And that's probably why you guys had it pitched up like that. So I think that you just had maybe a large incident angle. Alright. I think we have to limit this 0.1 so I don't blow up those dynamics. Rudder. Elevator. Go back to your aerodynamics that you had just so I'm not changing stuff for no reason. Didn't seem to make any difference. So 10. Alright, so that CL of 2 is why we get this crazy, and it feels like it's stalling. So something is stalling here. So let's do some debugging. Show you how this aerodynamic plugin works. If we go into wing left and we put a verbose tag, then we can see the math behind it. Alright, and wing right, wing left. H-tail, B-tail. So now we're going to get a ton of data, but hopefully something tells us what's happening here. So initially we're stalled because we have a large angle of attack, so I'm not too surprised about that. Alright, with those aileron limits, pretty hard to control it. So this is kind of banking over, and yeah, okay. So I'm going to pause it real quick and see what it kind of looks like while we're So vertical tail looks fine. H tail. Let's get a different one. So wing right. Lift coefficient of 1. CL of CL 0 of 1. CL is 0.26. I don't see anything obvious. I think we just have to run with it. Alright, so Team 12, let's get you a data set. And this is just too small for me to do anything. I need more control. Just try not to over deflect it. Okay. Okay, going stabilized. Oh, that looks about right. I can't blow it up, and pretty quick. Do what I can to tune it here. Alright, time constant. Alright, there we go. Speed up all the gains at once is what that is. Alright. I think that might have been the answer. It's probably pushing it a little bit. And let's see what we're cruising at right now. We're at 15 meters a second. Airspeed trim, that looks right. Okay. I'm gonna have to dump some altitude with that CL2. It's going crazy. So, oh, so let's look at this from the outside camera. Maybe stabilized will be able to stave it. Yeah. Yeah, we're just in a spin. I'm going to look at the aerodynamics when it's doing this thing. There's a large negative CL, stabilized. Let's get around the course. Position control. Alright, so made it through the green. See how blue goes. Alright, there we go. It looks pretty nice. So it just took a little bit of tuning to get this thing kind of in where we need it to be. And I think, it's partly the large lift coefficient and then the low wing. So probably not going to happen with black. Yeah, no. Alright, let's go in for a landing. Oh, see if I can save it. I took it out of stabilized and went to full manual, and then I lost it. I'm going to get a clean log and call that good. I just have to keep it stabilized. Okay, stabilized. Go for blue. I think maybe those gains went back to what they were at. I think they're set in the startup script, so I don't know. Try this. We'll just have to fix the moment coefficient. So this is going to probably be a little less. Just to note that this really should be fixed with a horizontal tail rate. So that's why I put check CM0 on all your stuff. And 0.5 check CM0, CD0, CMA. Alright, then the alpha stall change. So we need some more downward. Something is, there's something issue, but I haven't found it yet. I'm not sure. Seems crazy that it's got that much nose up, which, I mean, these should be negative on a cambered wing for CM0, so 2. That's a large downward, so it's too much for it to handle there. Alright, so I think that might have been a typo on the lift coefficient. It seems like we've got a lot better behavior now. Let's go to acro mode. I mean, we could use some more rate here if we're going to get around that course. So let's see what we got for gains. It's that feed forward, fixed wing roll rate feed forward that gives us that snappy response. Still really damped. Now I think we might need our aileron deflection back. So I'm not able to get enough response out of this thing. Alright, let's give that a shot. So I'm thinking that's starting to look more reasonable. Nope, out of battery. Alright, I think we're close to a log here. And then should be able to finish it up. I think it's good that you guys see some game tuning and things like that anyway. I just want to make sure that Team 12 gets a fair shot here. Yeah, it's definitely fixing that lift coefficient to be in a realm of reasonable improves everything a lot. But yep, I was able to lose it still. Let's turn off for Bose. Except for the motor. Yeah, I don't see anything there. There might be a typo here somewhere in this model that makes it so difficult to control right now, but I do not see it. That's why, I'm not putting too much weight on this performance. It is mainly for your benefit. Right? That looks correct. Well, we are drawing a lot of current. pull the throttle back a little bit, it helps quite a bit. Definitely one of the quicker vehicles, but and we just need, yeah, right now we're drawing too much current. It's around 5 minutes of flight time. The trim throttle I'm having to hold back a little bit. If I let it go forward, we're climbing quite a bit, so I'm going to see if I can limit the throttle a little. So we'll go to 80% throttle. It's 2 minute flight time. It's 850, 3750 kV with a 6 diameter prop. That helps a little bit, and it's still drawing a lot of current. So I can, if I bank and then pull on the stick, bank and yank, it really can zip around the corners. So no issue getting around the green course. But it takes some time to transition on the roll. Let's go to position control mode. It's not bad. This doesn't seem to be doing much to us, so I need to look more into this PID controller for the fixed wing. Not sure how to speed this up, how to speed that roll response up. Alright, well, we're almost out of battery. Let's see if we can get through the blue course. Roll limit, maybe 60 degrees. 90. Alright, you're going in for a landing. Try to get around the black. Nope. Alright, now I'm going to circle around for the landing. Oh. Alright. Got our log file. We got 2 groups left, so wrap this up. Try team 13. Make sure this all looks good first. Got that and data directory logs. Got team 12 now. Yeah. So all the XFLR5 analysis for that CLA and to control gain, and the CM to control gain to CM and control gain to CL, I stuck in this folder here. And this are the key ground control parameters and stuff that I've been playing with the Mini Scout, but those are kind of out of date at this point. So let's go next group, 13. Alright, we got a 1000 milliamp battery. Let's see how this goes. Nice takeoff. Alright, endurance is around 5 minutes during cruise. Yeah, I mean, this is kind of more what I would expect to see. So I don't know, Team 12, I think we'll have to just figure out if there's a typo somewhere in your model. I think that's what's happening right now. So I think you guys should have a response similar to this. I mean, I don't know why maybe one of those inertia terms is so big. But 13, you guys are doing great here. This is keeping right on track. I'd expect maybe it could get in black. I'm gaining a little altitude at a position control. So we are pretty zippy on this. It's a pretty low wing loading. I don't know if we'll be slow enough to do black, but we should definitely get blue. Alright. Alright, 12 meters per second. Yeah, no trouble with blue. I'm having a hard time getting the altitude controller to keep me at the fixed height. It wants to climb. It's got a pitching up tendency as it's trying to get that low speed. Um, I guess it's cruising at 12, and that's about all I can get. So I should just not hold the stick back. Just let it go with that. So it's trying to reach the minimum airspeed of 10, not doing a very good job of it. Alright, here's black coming up, 13. Let's see what our cruise is. Airspeed trim, let's set it to 12. Circle it back around and try that again. Does seem to have kept our changes here, so that's why it's pretty zippy. And with some of your aircraft, yeah, if we took some time tuning the control gains, we can get better responses. So, but what you're kind of starting with is kind of wing loading and power loading, and what you guys have done for the design is all really important. So this feels really tuned in. I feel like I can guide this thing anywhere. Alright, I might be able to do it. Nope. Alright, let's try it again. Part of this is pilot error. So I know that this airplane almost could do that. Maybe if I get a different view angle. Alright, now I just have to get low enough. Alright, that's low enough. See if I go, there we go. Okay, I don't want a close view angle, but at the same time not. Oh, pilot error. Alright, well, very robust. Static. Let's try this. If I do a min distance of, or max distance of 2, 4. Oh, we're almost out of battery, so this is the last run, and I'll have to glide into a landing after that. Oh, that's it. So, and we are out of battery. See if I can make it back. Alright, very nice flying. I really like that. Alright, great job guys. So let's grab the log file. So we'll copy this guy over to team 13, and the last team, so team 14. Alright, we have 650 milliamp hour. Looks like the battery's, oh, it's going to make it. Okay. We've got a little bit of a prop torque issue going on here. It keeps rolling to the right. So let's try this. Try it in position control. See how it does. I think by default, Q ground control is set up for gains of larger aircraft, but these little small guys, their settings can be quite different, as you can see, or time constants quite different. So the teams that have gone later have benefited from me doing some gain tuning here. But hopefully you all got to see your aircraft perform, and you're feeling good about that. If you have any questions, or if you want to try to improve your model, just let me know, and you can work with me on GitHub. and any changes you want to make, and I can show you how to get this flying on your computer. To fly this, you definitely want to be using Ubuntu Linux for right now because it's all using Gazebo and ROS. So if that's an issue, it can be a hurdle for some people to get into that. The cool thing is that this simulation we can easily add things like LiDAR and computer vision into it, and all the sensors are already set up to do that, and that's what really Gazebo specializes in. So for autonomy and control, oh, didn't make it. Oh, very close. For autonomy and control, when you want to do like complicated things with computer vision and path planning, and you want to make an autonomous vehicle, Gazebo is a really great tool for doing that. There's a lot of robotics built into it, so you could have like a ground robot interacting with the air robot and things like that. And I'm hoping that we get some of these actually built for the test facility, and possibly this summer I'll print some of them off and do some construction and see if we can get it flying indoors as we intended. But I really enjoyed the semester, and want to thank you guys for putting in the hard work. And I will see you around. And if you're graduating, congratulations. And I guess let's make sure we get this log file. We still have plenty of endurance. So I'm going to put it in manual so I can kill the throttle. Oh, there we go. Yep. There we go. Very nice landing. So that was an excellently flying aircraft as well, and landing stuck. We didn't quite make black, but definitely made blue and green. So great job, guys. And I think that's it. I will copy over the last log file and then post this so you guys have access to it. So we copy over 1025 to get catkin source fixed wing gazebo data logs team 14. Looks like we're missing the logs there. Alright, those are ignored. I wonder why that is. So anyway, we'll force add. says, huh, let me check this. Hmm. Yeah, okay. Let's not call that the log directory or logs. So this is maybe a little bit of an abuse here. This is too big of a file anyway, so let's see how big. It's not too bad. So now let's check it. If we go to GitHub, you should see all the logs here once we do that, and then I'll upload the recording of this video to Google Drive and send you guys the link. Alright, that's it. Well, thank you guys.